Hey guys, welcome back to another Anais Lectures video. Today is going to be another geometry one, and today we will be talking about the different centers of triangles. So this is another topic in geometry where you talk about after you've learned some of the special lines that triangle has. Now you're going to learn the centers of these lines. So the first one I want to talk about is the centroid. So the centroid is the intersection of all medians in a triangle. And as we've learned previously, a median of a triangle is where you have you go from the vertex of one vertex of the triangle to the midpoint of the opposite section. As if you can see in this triangle here, you start from this vertex and you go across to the opposite side, and it goes to the midpoint, meaning that it cuts the opposite side into two equal halves. And some properties of centroids are that they are always, no matter what, inside the triangle. They're always inside the triangle, like no matter what. Centroid will always be inside the triangle. So if you see that a point is being outside of the triangle, that's not a centroid. And then also another really cool property about centroids is that through the centroid theorem, we can then confer is that each median, once you have a centroid, each median is divided into a 2-to-1 ratio, or 2/3 to 1/3, meaning that as we have in this triangle, each median, say this median here, it's split perfectly into a 2-to-1 ratio, meaning that this part is two like parts, and then this is one part, meaning that if this total, say, was 24, just this part would be 16, and then just this part would be 8, because it's in a 2-to-1 ratio. And okay, so to solve for centroids algebraically, there is a formula. It's a very simple formula. It's that the centroid is equal to the let the vertexes be labeled as x1, x2, y2, y2, etc., etc. So the centroid formula is x1. So the x value of the first vertex plus x2, which is the x value of the second vertex, plus x3, which is the x value of the third vertex, divided by 3, and then that will give your x coordinate of your centroid. And then repeat the process for the y values. And let's just do like a problem for this one. So this question says, find the centroid of a triangle with the vertexes this. My first things first, I'm going to label my x1, y1, x2, y2, and then x3, y3. Now I'm going to follow the formula. So I'm going to start off with x1 plus x2 plus x3 over 3, comma, and then repeat it for y. So 2, because 2 is y1, plus y2, which is 5, plus y3, which is -1. Yeah, I'm going to do -1 over 3. And then when I compute that, I get 12 over 3, comma, 6 over 3, which is just equal to 4, comma, 2. That is your answer. That is the centroid of this triangle. Okay, the next center I want to talk about is called the circumcenter. So as we learned that the centroid was the intersection of all the medians, the circumcenter is the intersection of all perpendicular bisectors in a triangle. And what do we know about perpendicular bisectors? Perpendicular bisectors, they are lines that just go perpendicular to a side. So they are perfectly perpendicular to one of the sides. They don't have to necessarily be coming from a vertex. They just have to be perpendicular. Just like in this case, you can see that this line is perpendicular to this side of the triangle, since it creates that red and that 90-degree angle. But in this triangle's case, the perpendicular bisector does not necessarily start from the vertex. As you can see here, this line is the perpendicular bisector of this side, but it does not necessarily start at a vertex. And so some properties of circumcenters are that they do not necessarily have to be located in the triangle. The circumcenter, unlike the centroid, where the centroid is always in the triangle, the circumcenter does not necessarily have to be located in the triangle. And you can know where the circumcenter is located based on whether the triangle is acute, right, or obtuse. So if the triangle is acute, the circumcenter will be inside the triangle, as we've seen in this one. But if the triangle is a right triangle, the circumcenter will be located at the midpoint of the hypotenuse. And I've actually drawn it right here. This is an exact right triangle, and once you draw your perpendicular bisectors, you will notice that the white here, this white point where my circumcenter is at the exact midpoint of my hypotenuse. And then if you have an obtuse triangle, then the circumcenter will be located outside, just like I showed you this one. And then one last little like characteristic of a circumcenter is that the circumcenter is equidistant from all the vertices, meaning that that circumcenter is going to have equal distance from all the vertices. Just like in this one, this is equally distant from all three vertices. This is equally distant from all three vertices. And this one is also equally distant from all three vertices. Now let's solve for now let's figure out how to solve for a circumcenter. Well, the steps into solving for a circumcenter goes as such. So your first step is to find the midpoints of each side. So say that in the question you are just given the coordinate points. How do I go about this? Well, the first things first is to find the midpoints of each side, or you can just do two sides. It goes the same way. Me personally, I like to just do two sides because it's a little faster. But this finding the midpoint is genuinely crucial in solving the equation. I'll show you later. So we know midpoint formula is just x1 plus x2 divided by 2, comma y2, y1 plus y2 over 2, and that's done. And this is be important because once you find the midpoint of each side, you're going to set that coordinate point aside, and then you're going to calculate the slope of each side. Then take the negative reciprocal of that slope, so a perpendicular slope, and then you're going to write an equation for those perpendicular bisectors, because the whole thing is that we want to find the intersection of these perpendicular bisectors, because that is what a circumcenter is, right? So to find those perpendicular bisectors, you're not necessarily going to be given them. You're just going to be given the sides of the triangle. That way you have to actually write the equations of those lines. That's why. And then the final step is just to solve the system by making the two things equal each other. Okay, now let's solve like a question so that you understand how to do the circumcenter. So this question says, find the circumcenter of triangle ABC, and then it gives the coordinates. So following my first step, I'm just going to choose two sides, okay, of this triangle. For me, I want to choose side AB and AC, okay? So now I'm going to need to write the equations of the perpendicular bisectors of said sides, okay? So the first things first, like for AB, first things first, I'm going to find the midpoint, because I need to find a coordinate on the grid in which this side goes through, because that's the only way I'm going to be able to write my perpendicular bisector equation. So the midpoint of this AB is going to just be, I know the midpoint equation is x1 plus x2 over 2, so 2 plus 8 over 2 is 10 over 2, comma, y1 plus y2, which is 2 plus 2 is 4 over 2, meaning that the midpoint of AB is 5, comma 2. Circle this, set this aside. Okay, I'm going to repeat the process for AC. I'm going to do 2 plus 4, which is 6, over 2, comma, 2 plus 6, which is 8, over 2, which then equals 3, comma 4. Circle this, set this aside. Now, I need to find the slopes of each of these sides. So the slope of AB, I'm going to solve that by doing y2 minus y1 over x2 minus x1, which is going to be, 2 minus 2 over 8 minus 2, which is just equal to 0. Okay, and then the slope for AC is the same process. M is equal to y2 minus y1, so 6 minus 2 over 4 minus 2, which is equal to 2. Okay, this is my slope, this is my slope. Now, I'm going to take because this is the slope of my side of AB, if I'm solving for the perpendicular bisector, I know that the slope of the perpendicular bisector is going to be the negative and reciprocal of said thing. So for AC, I'm going to do the negative and a reciprocal of 2. So it's going to be negative 2, and then reciprocal is going to be negative 1 over 2. Okay, so now let's solve for the perpendicular bisector of side AB. So what we were doing earlier, so we had found the midpoint of AB, which is 5, 2. And then we also found the slope of AB, which was 0. Okay, as you know from the laws of algebra, if a line has a slope of 0, it is a horizontal line, meaning that AB is a horizontal line. Okay, so it's a horizontal line. It's a straight line like this, right? And it passes through 5, 2, meaning that if I took the perpendicular line to this AB line, it would just be a vertical line, right? And I know that it has to pass through the midpoint, okay? One of the qualities of perpendicular bisectors is that it goes directly through the midpoint of the opposite side. So, therefore, if line AB was horizontal, then the perpendicular AB, the perpendicular bisector of AB, is going to be a vertical line. And I know it passes through 5, 2, meaning that the equation for the the perpendicular bisector of line AB is going to be x is equal to 5. This is the perpendicular bisector of line AB. And then let's do the same thing for AC. So I took the opposite, the negative and reciprocal of my original slope, and I got negative 1 over 2. And I know that, so this is the slope of the perpendicular bisector. And then I always know that the perpendicular bisector passes through 3, 4. I'm just going to label this is my x1 and this is my y1 because I want to write it in point slope form. So I know that point slope form is written as y minus y1 is equal to m times x minus x1. Therefore, I can rewrite it as y minus 4 is equal to negative 1/2 times x minus 3. Now, this is the equation of the perpendicular bisector of AC. Now, I need, what am I looking for in the first place? I was looking for the circumcenter, which was the intersection of the perpendicular bisectors. Meaning that if I need to find the intersection between these 2 points, these 2 lines, I just have to make them equal each other. So, and because this is x is equal to 5, I just can substitute it in. So y minus 4 is equal to negative 1/2 times 5 minus 3. Then y minus 4 is equal to 5 minus 3 is 2. Negative 1/2 of 2 is negative 1. And then add 4 to that side. Y is equal to 3. Okay? So my points for my circumcenter are x is equal to 5 and y is equal to 3. And there is your final answer. Okay, now let's talk about the third type of center in a triangle, and this is the incenter. The incenter is the intersection of all the angle bisectors. And also, as you'll learn like later on in like Algebra 2 or Precalculus, the incenter is also known as the center of the inscribed triangle of any, inscribed circle in any triangle, meaning that if you had a triangle and you inscribed a circle, meaning that the circle was perfectly fit inside the triangle, the center of that circle is the incenter, or it is also just the intersection of all the angle bisectors. And some characteristics of the incenter is that it is always inside the triangle. Like no matter what, it's always inside the triangle. And it is equidistant from all sides, not vertices, sides. Like we learned earlier that the circumcenter was equidistant from all the sides. Here, we learned that the incenter is equidistant from all the sides, not the vertices. Okay, meaning that this incenter does not have to be equidistant from all these vertices, even though it looks like it is, but it is always equidistant from these sides. Okay, now let's figure out how to solve the incenter. Now, in most states' curriculums, you are not mandated to know how to solve for the incenter since it is a little bit more challenging, but here I will teach you how to solve it. So for the incenter, you first have to figure out something. So for incenter, let the side lengths opposite to the vertices ABC be labeled as lowercase ABC. And that might have been just confusing, but hold on with me. So say that you have this triangle, okay? And you have these angle bisectors that I'm trying to find what's the coordinate of this in center here. Okay, well, I have labeled my vertices as A, B, and C. That's naturally. A is my x1, y1, B is my x2, y2, C is my x3, y3. Now, the sides opposite to said vertex will be the side length of A. So I have vertex A here. The side opposite to vertex A is side A, meaning that side BC is technically labeled as lowercase a. And then the same math goes here. So the side opposite to vertex C is going to be labeled as C and B, etc., etc. So for the formula for in center is that you use the weighted averages of all the averages of all the side lengths, and it goes as such. So you have your A value, your side length of A value, multiplied by the X coordinate of your A vertex, and then plus your B side value, which is going to be like the distance, so that value side length, times your x2, which is the x value of the B vertex, and then repeat the process for C, divided by the total side lengths of all the sides. And then repeat that process for the y coordinates. And let's just do one really quickly so that you can like understand what we're solving. So this question says, find the incenter of a triangle A, C, and A, B, and C. Okay, my first things is I have the vertexes, okay? I'm going to label this as x1, y1, x2, y2, and x3, y3. Now, the only thing I'm missing are my side lengths. So what am I going to do? I'm going to compute them. So I know that side length A, as I've showed you, is technically just BC. So I know A is side length of BC, which I'm going to just use distance formula to figure it out. I know distance formula is the square root of x2 minus x1, which is 6 minus 0 squared, plus 0 minus 8. 0 minus 8 squared. And then that way I'm going to get the square root of 36 plus 64, and that equals 100. Square root of 100 is 10. Meaning that the side length for A, my side A, is 10. Now let's repeat the process for B. So side B, I know is going to be, if I have side B, that's going to be the side opposite to vertex B, which is going to be side AC, okay? And I can already figure it out because A is 0, 0, and the C is 0, 8, which means that they're both on the same, Y. They're both, not one is above the other, which means that the side length is just 8 because it's just one away, you know? And then the same process for C. I know C is technically side AB because it's the one opposite to the vertex C. And then C is also similar. It's just that you just do the difference between 6 and 0, which is just 6, and then 0 and 0 is 0. So this side length is 6. Now that I've found all my information I need, I can then set up my my formula. Okay, so my formula, I'm going to start off in center. And I'm just going to follow the same way that we did it. A times x1. Okay, I know A is 10, so 10 times x1 is 0. Okay? Plus, what was our B, plus B times x2? B is 8, and then x2, let me find it, is 6, okay? Plus 8 times 6, plus C, because it says here, C times x3. So C is 6. 6 times x3 is just 0. And then this is divided by A plus B plus C. What is A plus B plus C? It's 10 plus 8 plus 6. Now do this for the y values, okay? So it's just going to be A, side length A, which was 10, times y1, which is 0, plus side length B, which was 8, times a y2, which is 0, and then plus side length C, which was 6, times y3, which is 8, divided by 10 plus 8 plus 6. Now, all you have to do is simplify, and your answer should be that for the x, you should get 48 over 24, which equals 2. And then for y's, it should be also 48 over 24, which is also equal to 2, meaning that your in-center is located at 2, 2. Yay! Okay, so now our last center that I want to go over is called the orthocenter. The orthocenter is the intersections of all the altitudes of a triangle. Let's refresh our brain on what an altitude is. An altitude is the line which goes from the vertex. It always starts at the vertex and it drops perpendicular to the opposite side. And a property of orthocenters is that it does not necessarily have to be located in the triangle. And the way that you can also figure this out is just like with the circumcenter. If you have an acute triangle, the orthocenter will be inside the triangle. If you have a right triangle, then the orthocenter is located exactly at the right angle. And then if you have an obtuse triangle, the orthocenter is outside. And I can actually just show you some examples. Here we see an acute triangle, okay? And here I can see that all my altitudes, which go from the vertex perpendicular to the opposite sides, they all meet at the inside the triangle right there. But I have an obtuse angle right here, okay, obtuse triangle right here. It's this one. And notice here that when I go, I have to go from the vertex to the opposite side. But once I noticed when I was drawing it, like if you start from here and try to go vertex to the opposite side, it doesn't go perpendicular, right? Meaning that you have to extend the lines to figure out where it drops actually, and that's why the orthocenter is located outside. Now let's figure out how to solve for orthocenters. Well, it's the same process as we did earlier with the circumcenters, where you have to write the equation of two of the altitudes and then make them equal each other, solve the system. Okay, so now we are going to solve for the orthocenter of this following equation where it says, find the orthocenter that A is 1, 2, B is 7, 4, and C is 3, 8. So let's just get into it. So my first thing is that I'm just going to choose two sides. On me, I want to do sides AC, and then I'm going to do BC. Now, for these two sides, I'm going to be writing the equations of the altitudes of these sides. So I'm going to start off by the slopes. What's the slope of AC? Well, I'm going to do y2 minus 1 over x2 minus x1. It's going to be a minus 2 over 3 minus 1. It's going to get 3. Okay, so the slope of AC is 3. And then I'm going to do the same thing for BC. I'm going to do a minus 4 over 3 minus 7, which should get 4 over negative 4, and I get negative 1 as my slope. Now I'm going to take the negative and reciprocal of both of these numbers. The negative reciprocal for this one is negative 1 over 3. Negative and reciprocal for this one is 1. Okay, now that I have both of those slopes, I can start writing my altitudes, okay? So, because I have the altitude of side AC. If you think about it, when you have an altitude of side AC, you are going to go through vertex B, okay, when you're writing the altitude, meaning that I have this slope and then I have the vertex of B, which is 7, 4. I'm going to label this as my X1. This is my Y1. And then I'm going to write an equation. And I like to do point slope form because it's easy, but we can do we can just do normal slope intercept form. So I'm going to label that as my X and that as my Y. So 4 is equal to negative 1/3 times 7 plus B. Sorry. And then that you're going to get 4 is equal to negative 7 over 3 plus B. Then when you move out to that side, B is going to be 19 over 3. Meaning that the equation for the altitude, one of our altitudes, I'm going to use my B. And then I have my M, which was right here. I'm going to write the equation as Y is equal to negative 1/3 X plus 19 over 3. I'm going to keep this and I'm going to set it to the side. Now I'm going to do the same process for BC. I got my negative reciprocal slope as 1, meaning that my altitude is going to have a slope of 1. Now I'm going to solve for the y-intercept. I know that if I have the altitude of side BC, it's going to go through the opposite vertex, correct? And that opposite vertex of side BC is obviously A. So that's saying this slope passes through A, which is 1, 2. Label this as my x, this is my y. 2 is equal to 1 times 1 plus b. B is 1, meaning that the equation for line BC is going to be written as y is equal to x plus 1. Now we're almost there. Our last step is to just solve the system by setting both of these altitudes equal to each other, because what are we trying to do? We're trying to solve for the intersection of these altitudes, meaning that we just have to make the two things equal each other and then we're fine. So negative 1/3 x plus 19/3 is equal to x plus 1. Now I'm just going to I think I'm going to just multiply the whole thing by 3 to get rid of the, So then negative x plus 19 is equal to 3x plus 3. And then I'm just going to move this to that side and this to that side. Which I'm going to get 4x equal to 16. X is equal to 4. That is one of our answers. Now we're just going to plug in. So y is equal to x plus 1. I know x is 4, meaning that y is equal to 4 plus 1. Y is equal to 5, meaning that your coordinate for your orthocenter is going to be 4, 5. Thank you so much for watching. Please DM me if you have any more questions or requests, and thank you so much for watching.